process, that's mean the reaction by adding hydrogen. So we can say hydrogenation process, addition of hydrogen, add of hydrogen. So in this case we need 1 sigma, 1 pi. 1 sigma, 2 pi. For hydrogenation process, we need the all reactants should be unsaturated, right? Should be unsaturated. Maybe in or ine, alkene or alkyne. To complete this reaction, you should know that reactants should have pi bonds. Okay, 1 pi or 2 pi bonds. Let us start for the simplest one. If you have C2H4, ethene or ethylene, by adding hydrogen, we need in this case a catalyst. This catalyst may be nickel, may be platinum, may be Pt, palladium. Okay? First one here is nickel. To ionize hydrogen to H and H. In this case, we have carbon with carbon, 1 sigma, 1 pi, another carbon here, and we have hydrogen, the third one, the fourth. So in this case, we have pi bonds. Breaking down the pi bond at first, then add hydrogen to the first and hydrogen to the second. In this case, we can convert it to C, another C, H, 2, 3, 4, then add 1 and 2 here. In this case, it converts from unsaturated to saturated.
Yes.
From unsaturated to saturated, from alkene to alkene. Yes, what's the question?
لو بس زدت H4 مع H2 يطلع H6 صح؟
Yeah, directly, right? In this case, you can say this one is molecular formula, right? And here is structure formula. You should know both of them. The molecular formula will produce in this case C2H6. And here, by the same way, it will be CH3 by condensed form CH3CH3, right? This one is called 1. 2 is eth, all of them saturated, ane, so the name is ethane, right? Another one. If you have here, if we have C2H2, pay attention to this. C2H2, acetylene or ethane, that means we have here C and the second carbon, 1 sigma and 2 pi, right? And we have here 1 hydrogen with the first carbon and the second hydrogen with the second carbon. By adding hydrogen in presence of a catalyst like nickel, platinum, radium, and 1. In this case, we have H, one of them by breaking down this bond, and the second by breaking down, right? So in this case, we can convert it to C, single, and then it will be double, 1 sigma, 1 pi, and we have carbon. Here we have hydrogen, and the second here, that they add one, and hydrogen here in the second here, it converts from alkyne to alkene, right? Now, the question is, by hydrogenation process, addition of hydrogen, by hydrogenation process, can you convert acetylene to ethylene or ethene? I'll repeat the question again. By hydrogenation process, that means addition of hydrogen to acetylene, C2H2. It will produce in this case C2H4 ethene. Can we produce ethene or ethylene? Can we use this method for preparation of ethene or ethylene? I'll give you a hint. What will happen if you have excess of hydrogen? That means we have another hydrogen molecule here. What will happen? Another breaking down the pi bond between two carbon atoms, right? That means here another addition will produce in this case CH3. This one is ethane. So, can you control this reaction? How? Can you control 1 mole by 1 mole of hydrogen? No. So in this case, we cannot use hydrogenation process to convert acetylene to ethene. That is because or due to we cannot control hydrogenation process. It will produce another molecule or new molecule of ethane, right? Completely hydrogenation. Or between what's meant by hydrogenation. Hydrogenation process, that means addition of hydrogen. Add hydrogen. How can I add hydrogen? The molecule here should have a pi bond, right? By breaking a pi bond between two carbon atoms, that means add. We can add in this case. After breaking down the pi bond between the two carbon atoms. Okay? Another case. If we have benzene, look at this one. We have here benzene. C6H6. Double, single, double, single, double. And we can draw it by another way, like this. Double, single, double, single, double. We can draw it like this way. That means where is the double bond? Double, single, double, single, double, single, it's okay. Like this way or this or this. The scientist who made this structure, his name is August Kokoli. August.
Can you write his name, Mr.?
Yeah, I'll write it. Okay, August Kokoli. In this case, how can we draw it as a structure formula? C and 2, third, the fourth here, fifth, hexagonal shape, right? Put the double here, single, double, single, double. So each carbon in this case, Mr. Anas, needs only one hydrogen, right? Yes. To complete form. So in this case, we have H here, and H, excellent, and H. So we can say benzene ring is C6H6. Mr. Muhammad, how many pi bonds here? How many pi bonds? How many pi bonds?
1.
No? 1, 2, 3. Right?
Yes.
From this one, how many sigma bonds? Yes. Count or? Count.
3.
6 with hydrogen, right?
9. Yes.
And another 6 between carbon, right? That's mean 12. Right? Back again. Okay? When I ask you about the double bond or pi bond, check here. How many double bond? 3. How many pi bond? 3. How many single bond? How many sigma bond? The same.
12.
Okay? Between carbon and hydrogen sigma, there is no between carbon and hydrogen any bond except sigma. Because hydrogen is 1s. 1s is symmetrical sphere. It cannot make horizontally or parallel, right? It should be head to head only, right? So in this case, 1s hydrogen make only sigma. But between carbon and carbon, we have here sigma bond. Between this carbon and this carbon, we have sigma and pi. 1 sigma, 1 pi. Okay? 1 sigma, 1 pi. Mr. Keshava? Done? Okay. Now, Mr. Nawaf Patel. Pi bond here. We can break down them, right? That means hydrogen will add here and another hydrogen add it here, right? Hydrogen will add it here and hydrogen add here. Hydrogen add to this carbon, hydrogen add to this carbon, right? So 1, 2, 3, 4, 5, 6 add, right? So in this case, we can convert it to this compound, saturated compound. Is it a chain or cycle? What is the name? Cyclo what? Hexane. Cyclohexane. So by completely hydrogenation of benzene, we can convert it to cyclohexane. So we can convert it, this one, from pi bonds here unsaturated to all of them sigma bonds saturated. It's okay? Now, I'll repeat again. Hydrogenation process. Add hydrogen. That means we need, in this case, the compound has pi bonds. That means the compound is unsaturated. We can convert it to what? To saturated. By converting all pi bonds to sigma bonds only. Okay? Now, I'll give you here a question and think. I'll give you a hint at first. The number of double bonds equal the number of hydrogen moles which we can add. By another way, the number of pi bonds equal the number of hydrogen moles or moles of hydrogen which we can add. Look at this one. We have here CH2 double CH2. How many pi? How many pi? 1 pi, right? How many double? 1 double. How many moles of hydrogen you need? 1 hydrogen. 1 mole. I'll repeat again. I will repeat again. Okay? 1 by 1. Here we have C single, then we double C, we have 2 hydrogen like this one. Breaking down the pi bond, then add hydrogen here, hydrogen here. That means we have in this case H2, 1 mole of H2, right? Check here this sentence. The number of double bonds, the number of pi bond equal the number of hydrogen moles or moles of hydrogen which we can add. Don't forget this hint. Okay? I'll give you in the exam exactly question like this without this hint. I'll repeat the hint again. The number of double bond or number of pi bonds, okay, equal the number of moles of hydrogen which we can add. Okay? Mr. Hamad Sige. Hamad, you have in benzene here how many double bonds? 3. How many pi bonds? 3. How many moles of hydrogen you need to add to convert it from unsaturated to saturated? 3. Hydrogen here, that means 1 mole. Hydrogen here, second mole. Hydrogen here, third mole. Right? Yes. That's addition. It's more easy. Don't forget this. The number of double bonds, the number of pi bonds equal the number of moles of hydrogen that we need to add, right? To convert it from unsaturated to saturated. Leave it mobile. No, leave it. Leave it. Okay? Now, I'll give you practice one by one. No off. I give you here CH triple CH. Okay? How many moles of hydrogen you need to add and convert it from unsaturated to saturated? How many moles of hydrogen? I want to add here H2. How many moles of hydrogen?
3.
He said 3. Is he right? I didn't ask you. The third time for you. Yes, Mr. Romani? 2. Why 2?
Because we have 2 pi bonds.
Excellent. We have here 2 pi bonds only. If you have between 2 carbon atoms, sigma, 1 sigma 1 pi, 1 sigma 2 pi. Okay? So the number of moles you need here, N equals 2 only. The coefficient of N here, okay, the number of moles, N equals 2 only. 2 according to we have here 2 pi bonds. We have 2 pi bonds. Don't forget it. It's okay?
If we cancel the 2 lines.
Excuse me?
If we cancel the 2 lines.
Okay, like, I'll give you another one. If we have, doctor, here, CH3 bond CH3, how many hydrogen moles you need?
This one?
According to my rule.
No.
Nothing, right? So, if there is a reaction between alkane and hydrogen? No. Hydrogenation process takes place on iron, benzene, anything like unsaturated to convert from unsaturated to saturated. Okay? That means we have no reaction between alkanes and hydrogen. There is no hydrogenation process, okay, between alkane and the hydrogen, right? No reaction here. Another one, look at this. The question is, how many moles of hydrogen you need to convert it from unsaturated to saturated? 3 hydrogen or 3 moles of hydrogen. 3 moles of hydrogen. Okay? Again. How many? Yes? No. After, if you answer this question, how many moles of hydrogen you need to convert from unsaturated to saturated? Can you answer it? You cannot. Why?
Means, can I go to my answer this one?
Yes, Mr. Khan? Four.
No.
Right. 1, 2, 3, 4. Only. It's more easy question. It's more easy question.
4 more.
Okay?
4 more.
4 moles of hydrogen. 4 moles of hydrogen. According to the number of pi bonds, right? Okay, Mr. Hamadi.
You need 6 moles.
6 moles. More easy now?
It's easy.
Easy. Okay. Shabab, who can give me the name of this compound? Think. Think.
Saturated or unsaturated?
Now, 1, 2, 3, 4, 5, 6,
Hex.
7.
Hex.
Check.
Hex.
No, hex. Check the numbers. Back again.
Heptene.
Step by step.
1, 2, 3, 4, 5, 6.
How many triple? 3. Triple is iron, right? Good. Until now, 1,
4.
2, 3, 4, 5, 6. At carbon number 1 we have iron. At carbon number 4 we have iron. At carbon number 6 we have iron. That's mean tri-iron. Tri-iron.
You have them triheptide.
Yeah.
It's the dash.
Dash 1, comma 4, comma 6. Dash tri-iron. Tri-iron. Tri. Okay. Iron. Okay. If I give you this one. From which carbon we can start? From left to or right? Right. Right or left?
Right to left.
No, right only. Yeah, right to left.
So,
1, 2, 3, 4, 5, 6, 7. Yeah? The same. If you have here 1, 2, 3, 4. It's okay? Yeah, that's better. Yes. 1, 3, 5. That's better. 1, 3, 5.
1, 3, 6.
1, 3,
6.
6. 6 is better. Right, Mr. Ahmed? 1, 3, 6. From this one. That's good. And the excellent. Thank you. So we can write here 1. Yeah, take bonus. 1, 3, and 6. Not 1, 4, 6. That's right. To the lowest number. Thank you. In this case, one by one. Check now. 1, 2, 3, 4, 5, 6, 7. 7 is hept. Dash. 1.
Comma
5.
No, 2 or 3.
Comma 5.
Is it
1 in.
the same?
No. 1 dash. I don't know what dash.
1 dash
5.
in.
And
5 dash I.
لا مو
Look at this one. Hept, number of carbon. 7. In. Okay, we remove E here, right? And don't forget. In. Alkene.
Yes.
Double, right? Iron.
Okay.
Okay? Easy? Okay. Another piece.
You have to start from the right to the left.
One by one.
Left to right.
From left to
Left to
right.
right.
1, 2, 3, 4, 5, 6, 7.
Hip dash.
7 is hip.
Dash.
Dash. 1
1 dash
in
dash
Dash.
3 dash
3,
dash
comma. 5 dash
لا.
dying. Dying. I'll repeat again. Okay? Okay, Jonas, 1 minute please. Okay, now we have hip, right? Dash, 1 dash in dash 3, comma 5 dash die in YNE according to the triple, and here for double, and here for the number of carbon. Thanks, sir.